A cable-stayed bridge has one or more towers or pylons, from which cables support the bridge deck. A distinctive feature are the cables or stays, which run directly from the tower to the deck, normally forming a fan-like pattern or a series of parallel lines. This is in contrast to the modern suspension bridge, where the cables supporting the deck are suspended vertically from the main cable, anchored at both ends of the bridge and running between the towers. Cable-stayed bridges were being designed and constructed by the late 16th century, and the form found wide use in the late 19th century. A suspension bridge is a type of bridge in which the load-bearing portion is hung below suspension cables on vertical suspenders. The first modern examples of this type of bridge were built in the early 1800s. This type of bridge has cables suspended between towers, with vertical suspender cables that transfer the live and dead loads of the deck below, upon which traffic crosses. This arrangement allows the deck to be level or to arc upward for additional clearance. Like other suspension bridge types, this type often is constructed without falsework. The suspension cables must be anchored at each end of the bridge since any load applied to the bridge is transformed into a tension in these main cables. The main cables continue beyond the pillars to deck-level supports, and further continue to connections with anchors in the ground. The roadway is supported by vertical suspender cables or rods, called hangers. In some circumstances, the towers may sit on a bluff or canyon edge where the road may proceed directly to the main span, otherwise the bridge will usually have two smaller spans, running between either pair of pillars and the highway, which may be supported by suspender cables or their own trusswork. In the latter case, there will be very little arc in the outboard main cables. An arch bridge is a bridge with abutments at each end shaped as a curved arch. Arch bridges work by transferring the weight of the bridge and its loads partially into a horizontal thrust restrained by the abutments at either side. A viaduct along bridge may be made from a series of arches, although other more economical structures are typically used today. An arch bridge is a bridge shaped as an upward convex curved arch to sustain the vertical loads. A simple arch bridge works by transferring its weight and other loads partially into a horizontal thrust restrained by the strong abutments at either side. A truss bridge is a bridge whose load-bearing superstructure is composed of a truss, a structure of connected elements, usually forming triangular units. The connected elements, typically straight, may be stressed from tension, compression, or sometimes both in response to dynamic loads. The basic types of truss bridges shown in this article have simple designs which could be easily analyzed by 19th and early 20th century engineers. A truss bridge is economical to construct because it uses materials efficiently. A truss is a series of individual members, acting in tension or compression and performing together as a unit. On truss bridges, a tension member is subject to forces that pull outward at its ends. Even on a wooden truss bridge, these members are often individual metal pieces such as bars or rods. A cantilever bridge is a bridge built using cantilevers, structures that project horizontally into space, supported on only one end. For small footbridges, the cantilevers may be simple beams. However, large cantilever bridges designed to handle road or rail traffic use trusses built from structural steel, or box girders built from pre-stressed concrete. The steel truss cantilever bridge was a major engineering breakthrough when first put into practice, as it can span distances of over 1,500 feet 460 meters, and can be more easily constructed at difficult crossings by virtue of using little or no falsework. Beam bridges, also known as stringer bridges, are the simplest structural forms for bridge spans supported by an abutment or pier at each end. No moments are transferred throughout the support, hence their structural type is known as simply supported. The simplest beam bridge could be a log, a wood plank, or a stone slab C-clapper bridge laid across a stream. Bridges designed for modern infrastructure will usually be constructed of steel or reinforced concrete, or a combination of both. The concrete elements may be reinforced, pre-stressed or post-tensioned. Such modern bridges include girder, plate girder, and box girder bridges, all types of beam bridges. They are usually placed over highways, waterways, or other gaps in the landscape to allow people, traffic, and even animals cross safely. In the pictures below, you can see some examples of different beam bridges.